Hello, my voice is coming.
Yes, hello. Everybody is very good.
Okay, so earlier it was a little problem with the connections, the sets. Good morning, all of you. So now this is the second day of the third international webinar on natural hazards and management. Okay, our team.
Yeah, I hear you.
Can I also record my this webinar in my computers? I need the permission.
Yeah, of course. 1 minute, please.
Okay, so you asked to the that at least I should make the record on my personal computers. So okay, Ramotarji.
Yes.
Okay, you should give little bit thanks to my delegates and some scientists and some scholars, some students is also who have joined, and then we will start later on. We have the 3-4 minutes. So Professor Ashok Singh is here. Please give me the 5 minutes to warm up and start this second day.
Okay. Well, thanks, Professor Vinod.
Okay, so
Good morning. Good morning to all scientists, professors, participants, dear students, and hope just like yesterday, the 2 days program will run very successfully, and I thanks to all the participants who have already joined and also will join the warm welcome to all the participants. And I request Professor Vinod Kumar Singh, who is convener of this international conference, to kindly conduct the technical sessions. Okay, so, Professor Vinod Singh.
Okay, thank you, Ramotarji. Once again, thank you to all of you who have joined here and those who have the lectures today in the scientific sessions and the valedictory sessions. And now this is the second day for this third international webinar on natural hazards and management. And earlier we have completed the 2 seminars in this series last 2 years in 2020 and 2021. And thank you to those contributors who have given too much opportunity for their lectures for the consequences in the third seminar too. So one of the Professor Ashok Singh from the Lucknow University. He is the Dean Engineering and Faculty there at the Lucknow University presently, and a lot of administrative work from the Lucknow University too. So I am waiting a little bit to the Professor Sergei Shvetov. Might be he's little busy and he art him.
Unfortunately, I can't find him at the institute at the moment.
Okay, just you maybe ring phone to them. It will be better if he will be present here. Is either meeting or somewhere others?
Yeah, maybe.
Make ring call. So now we are ready to start. Can we give 1-2 minutes, Professor Ashok Singh ji?
1 minute.
Professor Ashok Singh, please tell a few words so that we can listen your voice, because I think some problem in your voice. Maybe increase your volume.
Hello, good morning to all of you.
I need your microphone. I need your microphone very close to your mouth. Okay. Little yes.
Am I audible?
Now it is better. Okay.
Huh? Okay,
yes.
no problem.
So, okay. So
So
that's
good
I was
morning to all of you.
just wait 1 minute. Maybe just I asked Artem, should we start? Maybe Sergey will join later on.
Sure, you can start if you are ready. All
Okay,
other
so
participants are here. You can start. Yeah.
oh, okay. So now we start our scientific sessions. The Sergey will join little bit soon or later. So okay. So Professor Ashok Singh ji, your topic is the space weather and climate changes. So this is a very interesting topic. So you have to see the correlation between the space weather and what is the climatic changes which is affecting on our society. Please, Professor Ashok Singh ji.
So let me first thank you to the organizer, especially Professor Binod Singh, for giving me this opportunity. And let me share my screen as well.
So go to the share, okay, and then okay. But no, this is your email is sharing WhatsApp.
Just wait, just wait.
Okay. Open your file. Maybe close this list. Okay. Otherwise, you can do from the downsides. Downside, come downside your mouse. Okay, click here on the.
Is it visible?
It's okay, but full screen. You know how to do it. Yes. Click it. Okay. It's okay. Now it is the full view.
Yeah.
Please
So,
start.
once again, I thank to the organizers for giving me this opportunity. And as the Professor Binod said, the topic of my talk is the space weather and climate change. So today we will talk about the space weather. And when we say space weather, it simply means that we are dealing with the sun and terrestrial environment, both. So if we define space weather, it refers to the condition in space that can influence the performance and reliability of space-borne and ground-based technological system and can endanger human life on Earth. Ye actually one paper we published in 2003, then this was the definition. But right now, the definition has changed. What is that? Highly dynamic and variable conditions, that is variation in plasma speed and density, solar magnetic field and radiation density in the geospace environment, including those on the sun, in the interplanetary medium, and in the magnetosphere, ionosphere, thermosphere system, and consequences of these variations into the system. So now this is that space weather, which is actually upper space phenomena that is impacting to the Earth environment as well. So it is very important to have the knowledge about the space weather and that their impact or its impact on the climate change. So here we can see when we talk about the weather, it simply means we are very much known to earth weather, that is weather on the earth. And when we say weather on the earth, so physical parameters that determine or describe the weather on the earth, they are the temperature, pressure, wind speed, and direction, relative humidity, dew point, cloud cover, and recently El Nino and La Nina discharges have also taken place. So tornadoes, earthquakes, climate change, these are related with, these are the phenomena that described by the earth weather. But today we will talk about the space weather, which is totally different than these parameters, because space weather consists parameters like solar wind, coronal mass ejections, solar flares, aurora, prominences, storms, substorms, and all these things. So first thing is that what are the causes or what are the physical processes that influence or that govern the space weather activities, so that may be attached with major two activity, that is solar activity and geomagnetic activity. And when we say solar activity, so it is simply, these are the solar wind, solar flares, and coronal mass ejections. It simply means that these parameters are related to the sun. And when we say geomagnetic activity, it is storms, substorms, and aurora. Some other parameters are agents. Let me say they are the radiation belts, cosmic rays. They also contribute to the space weather. But when we say space weather, the hot spot or the epicenter of space weather is our sun. These are some basic facts about the sun. Here we have listed about the solar emissions. That we are all known to this fact that the 95% of the solar energy reaches us as sunshine, that is in the form of light or heat, and photosynthesis are the part of that, that is sun weather, sunburn, weather, all attributed to this energy. But remaining 5% of the energy determines space weather. So here we are very particular that we are not going to describe or discuss about the total solar emissions, but we are going to describe the contribution of solar emission up to only 5%, which contributes for the space weather. So when we say space weather, so obviously there are some specific regions, or there are some particular phenomena which are responsible for these changes. So one of them is the differential rotation of the sun. This differential rotation, here we can see that the rotation time is changed as with the axis changes. So the different part of the sun rotates with different velocity, and so it takes different time. So this differential rotation gives reason to the sunspots, which are the very important parameter to describe or discuss the space weather parameters. Another parameter is sun's magnetic field. So sun's magnetic field and differential rotation, these are the major region which contribute for the space weather phenomenon. As I said, the sun spots, many of us is known that these are the dark areas on the solar surface, contain transient and concentrated magnetic field, and their size they may be moderate size sunspot, and that may be equal to the size of the earth or even bigger. But when we see what are these are nothing but, these are not the spot, but these are the regions. Let me say this region. So this region is nothing but, this has lower temperature to its surroundings and high magnetic field. So lower temperature and high magnetic field makes a spot that is called sunspot. And we all know that the sunspot have their importance role in the solar activity measurements. So as I said, the space weather is basically sun related phenomena. So sun's corona, which is expanding always continuously, is the primary part for this phenomenon. And another thing is that solar wind. Here we can see that the continuous solar wind is flowing and that reaching towards the interplanetary space and coming to the earth. Another parameter is solar wind, which can, here we can see that, and if we go some particular things about the solar wind, so their speed may be, or average speed may be 400 kilometer per second, and number density is around 7 per centimeter cube. Magnetic field is around 5 nanotesla. Electron temperature is order of the 10 to power 5 Kelvin, and proton temperature is order of 3 into 10 to power 4. So these are the parameters which contributes for the space weather. Then comes the solar flares, as it is shown in the figure. It is the flares, the energy is coming out of the sun in the form of flares. They are solar flares. Similarly, here we can see huge amount of coming into the interplanetary space from the sun surface, and it is reaching towards the earth. Then comes the coronal mass ejections. This is, as the name, it is the mass ejections or heavy mass ejections from coming from the sun through the interplanetary space is reaching towards us. So in overall, it creates just a concept that these much amount of energy is coming towards the earth from the sun. So what is the impact of these phenomenon on the earth? And earth contributes to the space weather? Yes, because it has magnetic field and an atmosphere. So this is the combination of, we just read about the sun's activity. We will go to the earth activity as well. So this is the sun-earth interaction, which combinedly give the impetus for these particular problem. So here we can see that these are the sun, this is the sun. So energy is coming in form of coronal mass ejections, and this is the interplanetary magnetic field which governs or which represent the interplanetary space. And totally this energy in the form of solar wind is reaching towards the earth and hitting at some particular point. This is actually bow shock. So at this point, this hits the earth surface or earth boundary or boundary of the magnetosphere, that is also called magnetopause. So sometimes this pressure energy from the sun side is higher than the energy from the earth side. So it breaks the magnetic field lines of the earth and enters into the earth system. So here we can see that different breakage magnetic field lines. And one thing is special here, to say that when these magnetic field lines are break, they again produce energy. So the huge amount of energy coming from the sun enters into the atmosphere of the earth. So it creates addition of the energy, and it sometimes it is called storm or solar storm. And here we can see that these magnetic lines, they are braked, and at a particular time they are reconnected. And then again, when these magnetic field lines are reconnecting, that is when they are breaking, they are producing energy, and when they are getting reconnected, again they are producing energy. So this amount, this regular amount of energy is reaching towards the earth. It creates the problem. So this energy which is coming from the sun interact with the earth and enters into the earth system is called storm, and this some sort of regular phenomena which is occurring here, and energy reaching to the earth surface, this gives the substorm. So this substorms are the result of sun-earth interaction. So here we can see that these result of sun-earth interaction are the geomagnetic storm, magnetic substorm, magnetospheric substorm, and auroras. What are auroras? We are very much collaborative with the Russian people, so they will know that from their roof they can see this type of good looking scene from their roofs. So aurora is of two types. When it happens in the northern hemisphere, it is called aurora borealis or northern lights. When it happens in the southern hemisphere, in the part of Australia and New Zealand, it is called aurora australis. So this geomagnetic storm, magnetic substorm, and aurora, these are the result of sun-earth interaction. We again come to our basic point, that is space weather. So when we talk about the impact of the space weather, here we can see that the many more impacts of the space weather. It starts from the satellite to aeroplanes, it comes to the ground, or even pipelines, power lines, which are based on the ground. But here we are concerned only one topic, that whether this space weather impacted to our earth climate. So answer is yes, but how much? For that part we have to go for few more slides. Here we can see that the energy distribution of different phenomenon, or the energy distribution for the different particular incidents. So here we can see that this is thermonuclear energy from the sun is coming in the form of electromagnetic emissions, flares, irradiance. Then if we come to this point, apart from this, all these are related with the sun's energy or sun's radiations. But we come to this point, this irradiance produce waves in the middle atmosphere, and then it is reason for the climate change in the troposphere. So energy coming from the sun is how impacted our climate, or how the climate change is being done or impacted by the space weather. Here we can see that the major drivers for the climate contribution is the solar irradiance, greenhouse gases. Here we can see greenhouse gases, and volcanoes. Here is the volcanoes, and INSO, that is El Nino Southern Oscillations. So here we can see that these are the factors that describe or decide the climate parameters. But in this particular talk, we will restrict ourselves to the solar irradiance. So here we can see that how this facular brightening and sunspot darkening, this is nothing but this is the high solar activity period and low solar activity period. This red color signal show the high solar activity period, and this blue color signal shows the low activity period. Here, if we see the particular impact of all these incidents, so here you can see that the carbon dioxide, effect of carbon dioxide, that is CO2 is increasing rapidly on the climate. Then global precipitation anomaly, global sea ice extent, global mean sea level, global temperature anomaly. Where global temperature anomaly, here we can see this is again increasing, and this may be related, or this may be concern for the global warming. And the last panel, that is this one, the first panel, the total solar irradiance. Here we can see that there is not much changes in the radiation coming from the sun and reaching to the earth. So if you further go for this particular, so comparison of global surface temperature change shown by this red line, and the sun's energy received by the earth, that is irradiance. This is the temperature, global surface change in the temperature, this red line, and this yellow line indicates the solar irradiance or solar radiance. We can see that, or we can compare that this particular parameter is more dominant than this parameter. So we can say that the solar irradiance or the solar effect or the space weather effect, they are contributing for the climate change, but the amount is very less in comparison to other parameters. So if we conclude that major parameters behind space weather phenomena, they are the solar activity, solar wind, solar flares, coronal mass ejections, geomagnetic activity may it includes storms, substorms, auroras, ionosphere, radiation belt, cosmic rays. Other than scientific aspect, space weather have equally important for societal and economic point of view. So it needs more and more attention in future course. But the question is whether climate is changing. Answer is yes. What is the relation? What is the factor, or how much it is changing? So anthropogenic factors are more responsible for climate change than the solar influences. So thank you very much.
Thank you, Professor Ashok Singh, for such very nice topic covered for the space weather and climate change. Any questions from the audience, please?
Yes, if possible, I will ask.
Yes.
Yeah.
So, Professor, my question is very simple. If we will try to compare influence in percentages, influence of space weather and Earth weather on the Earth itself, which is bigger? Whose input is much more, or how it differs?
Very good question. See, what is the space Earth weather? We are very much known for the impacts of all these weather. That is, there are tornadoes, cyclones, and all these things, even earthquakes. But as well as this space weather is concerned, that is not impacting directly. In fact, it is impacting indirectly. It is influencing anything. For example, if we, as I said, these impacted to the technological infrastructure, even power lines or pipelines. So impact is not that much is visible as compared to the earth weather.
Okay, thank you.
Anyone's more questions? Can you stop your sharing, Professor AK Singh?
Okay.
Any question from the audience? Anyone's? So, okay, thank you very much once again, Professor Ashok Singh. So you have given me the time, given us the time, your valuable time among your busy schedules. So once again, thanks. Now,
Thank you very much to all of you, and have a nice day.
Okay, once again, thank you. So I will not take your too much time.
Okay.
So if you are to go to the, then you can leave the webinars, because I know you are busy scheduled for the meetings. Okay, so now Professor Dr. Shantanu Sarkar. So the next.
Yes.
So your topic is, sir, slope stability assessment along hill roads. So the Dr. Shantanu Sarkar is from Central Building Research Institute, Roorkee. Okay, sir. So please share your slides. And
how much time I have?
Sir, how many times you want?
Okay.
Not more than 20 minutes. It's okay, I think.
Okay.
Because you have to give the others too. Okay.
Thank you.
Okay, sir.
Is it visible? Hello.
Yeah, it
Yes,
works.
yes, it is visible,
Okay.
sir.
Okay. Good afternoon to all of you, and I thank organizer to give me the opportunity to present our work. So the topic, as Professor Singh told, that is a slope stability assessment along hill roads, and this is one of the important aspects in Himalayas, where hill roads are mostly affected by landslides. So my outline of presentations will be like this: landslide problems along Himalayan roads, engineering geological investigation, and rock slope stability assessment. If you see the landslide data which I have taken from Fraude and Petlet 2018, then there are many as anthropogenic factors are coming these days which are triggering landslides. And in India, the data says that around 30% landslide events triggered by construction of roads. So that's why the stability assessment along the roads is very important. Now, landslide problem along hill roads of Uttarakhand Himalayas. I'll show you some pictures. Now, the landslide occurrence along the highways of Himalayas is increasing due to high rainfall intensities coupled with aggravated road and other infrastructure constructions. In the Uttarakhand state of Himalaya, from which I belong, there are few highways which goes to border areas also, and some tourist spots and the pilgrimage sites. So those roads are always occupied, particularly during the monsoon season. That is the time where people and vehicle they go to the pilgrimage sites. And the same time, due to heavy rainfall and all, landslide occur. So a very good detailed investigations and slope stability assessment is very much required. So you can see the condition of the road and the slopes here. Now you can have a look that there are chances of rockfall here. There are potential zone for planar slide, rock slide. And here also you can see that this is the highway, and there are always a potential zone for rockfall. See here, you can see the conditions of the road. Of course, these days, we have the government has widened the road, and things are getting better. But still, there are many vulnerable spots where the traffics and lives are always at risk. And you can see here, this is the road, and this is a vehicle, tiny vehicles you can see, and this is a huge rock slide which occurred in 2007. And the same slide, you can see that there are so many boulders which have come to the road. So the traffic was blocked for 1 or 2 days till the border organization, they cleared the roads, and vehicle traffic started moving. And so in the Google image, you have already mapped these areas and declared is a hazard prone area, where continuously at this hill, we have a 2015 slide here, then 2017 slide here, And again there is a, this time also there is a landslide in the same place. You can have that this 1 kilometer road is very prone to landslide. You know, here is there is a rock slide here, and there is a chances of rock fall here. Now, field investigation of rock slope, which we usually do, is that basically there are debris slide and soil slide also, but rock slides are very important when we investigate this along the hill roads. So we investigate the rock type, rock mass structure, their joint attributes, the joint conditions, that is roughness, weathering, infilling, joint waviness, joint alteration. Then rock quality designations, that is the RQD. It gives what is the intensity of fractures and joints within the rock. Then the joint shear strength properties and joint roughness coefficient, joint wall compressive strength. Then the strength wise, it is uniaxial compressive strength. So we determine by taking some rock lump from the field and get it done in the point load testing machine, or we use Smith hammer for getting the UCS of the total rock mass. So we determine the UCS of the intact rock also, and the UCS of the rock mass also. Then hydrological conditions, and the most important is the relation between the slope direction and the discontinuity. If they are parallel, then there is always chances of more landslide. If the beds are dipping inside the hill, then there is a less chance of landslide. So that part is very important. So in the field investigations, I can see that these are the spacing of different joints which we measure. Then there are joint conditions. Here there are 3 sets of joint. So you can see here that the joint spacing varies from few centimeters to a meter. So we take the data and take the average. So here you can see that the joint spacing is 10 centimeter here, is a 30 centimeter here. So for each joint set, we collect the different data like spacing, then its roughness, the opening, filling, and the weathering conditions, and also the strength parameter of all the joints. So here you can see that joint conditions, we have a closed joint also, the surface is smooth, sometimes surface is rough. And here we are taking the data of the slope and the rock dip directions. And here you can see here that the slope direction is somewhere 60 degree north 185, where the dip direction of this joint plane is say around 45 and 45 190. So there is a very this slope and the direction of joint is almost parallel. So there is always chances of the rock slide along this slope. So this is called joint slope relationship. And also we get the profile of the slope with some instruments. And here I have shown you the use of a Smith hammer, which is a very easy tool to get the strength of the rock mass. And this is the point load testing machine where we test the rock lump. So in both ways, we can determine the UCS of rock. Then, okay, this is detail of the point load index formula. So I am not going into detail. So we have a formula to calculate the UCS from point load index, and also we can calculate the UCS of the total rock mass by testing with the Smith hammer. This is basically a rebound number. So the field data is an example of field data. We have the location, we have the discontinuity, different joint planes, we have the UCS, we have the rock quality designation, then condition of discontinuity, that is with this, it is roughness, weathering, and infilling, and then hydrological conditions and the slope dip relations. So all this data we gathered from the field. And then from laboratory investigation, if you have a good rock triaxial test, then you can test the rock triaxial, and you get the data of the intact rock. This is very good because you get some other parameters also which are useful for calculating the factor of safety. But in general, this rock triaxial system we don't have in all the institutes. So that's why yesterday I was asking Professor T.N. Singh that, if you don't have this data, then what to do it? So there are several other ways to estimate the rough estimate of the USCS. But if you have the rock triaxial data, then as I told you that there are many parameters which you calculate, particularly some Hook-and-Brown constant and some values, which are very essential to calculate the factor of safety. So it is always better that if we have a drill core with you, and if you have a accessibility of triaxial system, then you can always go for that. So these are the testing where you have a stress strain curve and you calculate the failure of the rock samples under different confining pressure. Now, coming to rock mass classification, which is very important for stability analysis. We generally people do on rock mass rating, slope mass rating, GSI. Yesterday also I saw some presentations which is based on RMR and CSMR. So basically in RMR we have UCS, RQD, discontinuous spacing, conditions. So these are all joint parameter. SMR is RMR and the orientation of the discontinuities, and GSI is basically a very useful tool where you can assess what is the quality of the rock, which is it depends on the rock mass structure and the surface condition of the joints. Now here you can see the rock quality designation. As we go for a drilled rock core, then you can always calculate RQD. As everyone knows, we can always calculate our RQD by adding the 10 centimeter or more than that rock sum. So basically it is a core percent recovery. But the problem is here that every time, every site, you don't get the drilled core log. So in that condition, what we do is that we calculate the joint volume, which is a sum of your different of the spacing of different discontinuities. So if you get this JV, then from this formula RQD is 110 minus 2.5 JV, you can estimate the RQD even if you don't have the core log. And geological strength index is an engineering geological evaluation of rock mass, and it is essentially based on the blockiness of the rock mass and the condition of discontinuities. And GSI chart represents a range of values for each rock mass class. But nowadays we are using, instead of range, we calculate the quantitative numerical basis to estimate the correct value of GSI. And this GSI is basically based on, as I told you, the structural rating and the surface condition rating. Structural rating means that what is the condition of the rocks, means the blockiness of the rock, and surface condition rating is what is the nature of condition of the joint surface. So now you see here, this is the GSI chart, and depending on your values of structural rating and the surface condition rating, you can plot your GSI. You can plot your slope value somewhere here, and then you get the GSI value. And rock mass structure is classified into 5. This is the intact massive rock. Then you have a blocky where you have a large joint spacing. Then we have very blocky where the joints are very closely spaced. Then we have blocky disturbed and then disintegrated. So based on
I think the voice from the Shantanu Sarkar is not coming. Can you make a phone call to Shantanu Sarkar? His net is left.
I hope his net is left.
Some problem.
Network problem is there.
Okay, so maybe then we can continue, and when he will join, we will ask for the complete his lectures. Okay.
Okay, okay.
Maybe the Makrusin. Actually,
Yes, I hear you. Do you hear me?
yeah. Actually, the problem is some Indian contents, because some net is not working. So I request you continue your presentation. When he will join, then. Okay, so this is the topic of the talk, the hazardous exogenous geological process in the Murmansk region, northwest Russia. So please, Makrusin.
Oh, thank you. Do you see my presentation? Okay.
Yes.
Okay. It will be a very short presentation, a very short report about hazardous exogenous geological processes which were activated during this year. So first of all, I would like to say that we have been monitoring these geological processes since 2016, and how to next slide. Oh, okay, next slide. Here you can see all our position of our observation points. During the engineering and geological survey, we use visualization of these geological processes, determination of morphometric indicators and current activity, characteristics of development conditions, and activation factors. The Murmansk region belongs to territories with a limited manifestation of modern exogenous geological process, which are related mainly to the surface and underground water activity. The geological conditions and the large volume of surface waters are the reasons for seasonality manifestation of the landslides. The first landslide in this area, it's Murmansk city and Nizhny Rostinskaya road. Here you can see first landslide, which happened on 8 May of 2020 year in the northern part of Murmansk city. The landslide mass blocked highway, and transportation was blocked in 2 directions. Here you can see railway road, and this picture was made in 2020, so you can see the road landslide. The landslide slope is composed of boulder pebble muddy material with a sand clay aggregate. The surface of the landslide is stepped, bumpy, with large boulders. And in this year, it's 2022, we can see the new activation at the same place, new landslide. Here you can see on the photo, road, railway road, and the landslide new activation in this year. Because in this year, in the spring, was abnormally intense snow melt, and so it was the main factor. Another example of the landslide which happened this year. You can see the road to the Teribirka, and not so big, but landslide that damaged the road. It happens on 20 April this year. And we will include this point to our observation area in future, during our future investigation. Also, we continue to monitoring the rave information which we observed in the Kola River Valley. Here you can see Kola River, and in this area we can see the Kildinskaya deposit of clay and unexploited open pits. And on the northern side of one of these quarry, we can observe V-shaped ravine. Here you can see it. So this rock represented by sandy layered clays of glacial marine genesis. And they lies on moraine covered by sea sands up to 2 meters thickness. Here you can see the same open pit and V-shaped ravine and clays, sandy material. It's one of our points which we observed every year. And another slide shows us another point of observation. It's a river Kola and bank of this river. It's located in the town near Laparskaya railway station. On the right bank of the Kola River, there are buildings in the immediate, you can see in the immediate vicinity of the erosion slope edge, which poses a risk of its collapse or sliding when the process is activated. The processes of river erosion are manifested in the destruction of banks, the sliding of soil, and the fall of trees during the high water. River erosion processes in the Murmansk region are seasonally active and occur almost everywhere in the valley of rivers and large streams. The current profile of most rivers in the Kola region is non-equilibrium, especially in areas where rest near tectonic blocks and submerged depression join. So we can see the debris material entering the rivers are represented exclusively by coarse-grained fractions, pebbles, boulders, and so on, other sediments. But that's all our points which were activated this year. And thank you for your attention.
Okay, thank you, Dr. Makrosin, for your nice talk. Any questions from the audience, please? My voice is coming. Hello, my voice is coming.
Yep.
Okay, so any questions from the audience, please? Maybe no questions. So might be our team. Makrosin.
Thank you very much.
Okay, so is Professor Zero is there for the presentation, or he is in the meetings? Can you contact him? Our team?
To Professor Zhirov?
Yeah, Zero, yeah.
Um,
Not idea.
I'll try to do this.
Okay, you ask to him and convey the message. Either he will present or not. I think now the Shantanu Sarkar has reconnected.
Yes. So
Okay. So please finish your presentations. I hope this time you will not lose your connections. Anyway, sir, it is not your fault.
yeah, sorry, there is a problem. I think now it is visible.
Yes, it is visible.
Yeah. So I go quickly that after RMR, the RMR calculations, we go for a rock slope stability assessment. So here you can see the slide that, there are two types of stability assessment. One is based on rock mass classifications, where we have kinematic analysis, GSI, RMR, and SMR. And another is the numerical modeling techniques. If you have a lot of data, then we can go for a FEM modeling with more Coulomb or Hogan-Brown failure than limit equilibrium method. And then you can synthesize all the analysis and take decision of the slope stability. Now, kinematic analysis, as I told, that it depends on the joint and the slope directions. I think I will show you the photographs where yes. So here you can see that for kinematic analysis, we have a joint dip and the slope dip. So we calculate the relationship between that, and then we know that what is the probable mechanism of failure, whether it is a planar failure, or it is a wedge failure, or it is a topple failure. So based on kinematic analysis, we get the idea about the mechanism of failure. And similarly, here you can see that there are two joint plane making a wedge. So, and the slope direction is along the intersection of the joint. So we can decide that the probable failure is along the joint wedge, that is the intersection of two joint planes. So slope stability assessment, as I told you about the slope mass rating, where we first calculate the rock mass rating, which are based on 5 joint parameters, and the rating of F1, F2, F3 plus F4, where F1, F2, F3 depends on the joint and slope orientations and their amount, and F4 is the method of excavation. So if it is a natural slope, F4 is 0, and if it is a I'll show you that if it is a blasting or mechanical, then it varies from +10 to +8. Natural slope, it is +8. So depending on the type of adjustment factor for slope excavation, the adjustment factor for different joint orientation, we have different SMR, and this is based on 5 classes, whether slope is stable or unstable. So you can see here, the completely unstable slope looks like this. This is unstable, this is partially stable, this is stable. So these are based on our SMR calculation of rock slopes along the hill road. So result of calculated UCA, GSI, RMR, SMR, we can have all this data where you synthesize all this data for a rock slope, where you can see here that I got GSI is 64, RMR is 72, and SMR 87. So based on this result, you can assess that, okay, what type of rock slope is there, whether it is stable, it is unstable, what type of rock quality there. So all the data we can have with this geo investigation. Now, slope stability assessment along Rudprayag, Sonprayag road. This is just an example. Quickly, I will show you. The data is there. Okay. So this is the, along the road, we have several slope studied, and based on the SMR classes, we have decided into 5 classes from stable to unstable. So this type of, slope stability assessment can be done when you have GSI, RMR, and SMR values. Now, for numerical analysis, we have to have more detailed data, right? So we can have rock type, we have RMR, SMR, GSI. From this GSI value, we can calculate. There are several parameters. I am not going into detail, but there are several parameters which we can estimate from the GSI. That's why I am telling you that GSI is one of the important factors to be estimated in the field. Okay, so based on this, we have calculated the factor of safety, generalized Hook-and-Brown also, and also Moore-Coulomb. There are different techniques you can study in any literature and get the factor of safety done, dry condition and also in the wet condition. So based on this, you can design your slope and what type of suggestive measures you want. So you can see here this is the road, and this rock block fell down in front of us. So how dangerous these rock blocks are along the road. So we need to study all those rock slope based on the method I just now told you. So here you can see that there are different factor of safety for a rock slope, where it is a dry condition, then is the wet condition. So the factor of safety decreases from 0.97 to 0.91, and the pseudostatic condition when you take the earthquake data. So if you have all this rock, factor of safety values of all the slopes, here this is your Bhagirathi River, this is the road, and these are the slope where I have calculated the factor of safety. So based on the factor of safety values, that is, you can see here the debris slide 0.86, here rock slide 0.86, 0.73. So based on the factor of safety value, you can produce a landslide hazard map along the road. Okay. And then you can plot all this habitation, bridges and other things, and can find out that whether these infrastructures are at risk from these landslides. And I'm not going into this detail of this thing, but these are some of the rockfall measures technique which people are using these days. This is a rockfall check fences. Then there are intercepting falling rock to rest on the slope. And recently in this year, you can see here, this is a rock slide, and the state government has taken some decision and they have installed some rockfall catch fences here. Similarly, there are gabion wall. You can construct some gabion wall, and it will check. Basically, it will check the flow of and rolling down of the boulder. This is also very good rockfall measures technique. And this is now in India we have started. This is a rockfall shelters. That means that there is a landslide here, so traffic is safe when it goes under this tunnel. This is a tunnel where half tunnel. It is near Rangpo when you enter Sikkim. So there is a landslide here, so they have constructed this tunnel. So in concluding remarks, slope stability assessment is very crucial for landslide risk management. Spatial prediction of landslide necessary before the temporal prediction for early warning. So that's why we are doing all hazard mapping. Quantified slope stability assessment of the vulnerable slopes can be carried out using rock mass technique and numerical analysis. Once the landslide potential areas are identified, design of mitigation measure can be taken up, and such a study should be taken up along all the hill roads to minimize the loss of life. The rock mass classification techniques such as GSI, RMR, SMR, and many other help in assessment of rock slope stability. And it is very important to select appropriate methods for slope stability analysis. So I don't know, I tried to give some information which we are doing, and my papers are there in our institute site. Anyone can refer to this. Thank you very much.
Thank you, Dr. Shantanu Sarkar, for such nice talk. Little bit disturbance due to the
Yeah, I'm
problem.
sorry for that.
I am sorry too. So that's any questions from the audience, please. So once again, thank you very much, Dr. Shantanu Sarkar.
Thank you. Thank you.
And is Ravi Bhaskar is there? Ravi Bhaskar? Not joined now.
No, he has not given any reply.
Okay. So maybe we can wait a little bit more. And I think our team, we should proceed. Dr. Jiro is not present, he is here. And maybe Harshita Joshi, are you listening me? Dr. Ramota Singh, who is present in the next speaker? The Mohit.
I will inform you. Yes. Mohit Puria can present
Mohit,
newspaper.
are you ready to present your talk?
Yes, sir. I am ready, sir.
Okay, kindly share your slides. And Mohit Punia. But who is okay? Okay, Mohit.
So,
What is your okay? Just you now present.
hello, sir.
Okay. Ramotan, can you see who is this class? Okay, so
Hello, good afternoon to all of you, sir. So today I got opportunity to show up some research work as well as applied work about the Joshiara Barrage. So Joshiara Barrage is situated in Uttarkasi district of Uttarakhand state, and it's a 300 megawatt project. So after 2013 disaster in Uttarakhand, this the right bank of this barrage that was means built up by filled up material and known as rock means mixed type of earthen embankment got has some seepage problems. So Uttarakhand Jal Vidyut Nigam Limited called me and they asked me to investigate this situation and suggest some solutions. So we go there and just a minute, sir. We go just this is the means aerial view of the Joshiara Barrage, as you can see on your screen. So the right bank of the Joshiara Barrage basically was seepage problems, and due to seepage problems, the downstream population, as you can see nearby in the loop, got waterlogging problems. Due to waterlogging problems, their houses were submerged up to some extent. So there is a voice to protect their houses. So we started investigation. As you can see the pictures, waterlogging problem in the downstream of the Joshiara Barrage at right bank. And now this is the situation after the investigation and treatment of the embankment. So you can see this is totally dry right now. When they means fill up the whole reservoir, and when this Joshiara Barrage attained its full reservoir level, this area means has been waterlogged up. So that's why we investigated thoroughly by geophysical method, geological method. Then we have tried to design the mixed ground design, and we tested mixed ground design for identified location. Those are identified by geophysical method and geological method in 3 triangles. Then as you can see, this was our investigation plan, in which we have taken up geological investigation that include core drilling, permeability test, because this embankment was built up on the overburden material. So we use constant head permeability method, not the pressure test. Then after means constant head permeability method, we conduct the post grouting test for permeability also. Means we want to test that if whatever grouting we are giving to the embankment, so what will be the effect. Then geophysical investigation. In geophysical investigation, we have conducted geoelectrical resistivity test, cell potential test, and seismic reflection tomography. Why we have conducted this geophysical investigation? Because we want to know the approximate seepage zone by geophysical method, then we can apply geological method, because core drilling method is very, very expensive. So we can't directly apply the geological method to to investigate the site. So first we apply geophysical, then geological. So we use these instruments, you are all aware about this. So we use seismic reflection tomography for the bedrock depth foundation. Then we use resistivity methods to know the recharge zone or saturated zone. Then we use self resistivity method also. So we took up to a profile along this right bank. As you can see here, the profile is represented by red line. So along this line, approximately 250-meter area along the embankment we have covered in geophysical investigation. So these are some relative resistivity values. As you can see, different types of earth material, rock as well as the loose material, shows different type of resistivity. So based on this principle, we determine the different types of layer. Those are saturated or unsaturated, and we differentiate it, then plan for geological investigation. So these are the some range of different type of earth material. So this is our tomograph of resistivity. As you can see here, and this is RD reference datum of 120 meter from dam axis to upstream. You can see this is the highly saturated zone here, and one saturated zone we have investigated or find out at the RD 0 RD meter. Then cell potential method so similar findings. Similar cell potential cavities or saturated zone we found in the cell potential method also. As you can see, the bedrock depth varies from 35 meter to 35 meter towards the dam axis, and when we go towards the upstream of the dam site, it's varies extend up to 41 meter. So what we have decided, after that, as you can see, these are the saturated zones. So we decide to drill here and conduct the permeability test. After that, grouting test, pre-grouting test, then post-grouting test. So we have prepared this is the constant head method we have conducted at the site. Now these are the cores. So all these cores are because this is the overburden. So this is the core from riverborne material. So there is no core bedrock encountered. Then we have conducted permeability test by constant head method, and the value of the permeability coefficient was 7.3 into 10 to the power minus 5 per centimeter second square. So we have conducted in one triangle, we have proposed 3 borehole for the pre-grouting, and then 1 borehole in the center. These 3 boreholes was designed at 2 meter interval. Then we drilled 1 more hole at the center of the triangle after grouting. So we want to check what the effect of the grouting here. So you can see here we have conducted, we have drilled 4 borehole, BH3, BH5. These are the IDs of the, and this is the center hole that is mentioned here as a triangle 1. So you can see the permeability coefficient value was decreasing after the grouting material. So here you can see this is the plan of the Joshiara barrage here. So we treat this right bank 0 RD to, this is the barrage axis, 0 RD to 250 RD. So one more method we have applied here, because this is the deep drilling grouting. If suppose that we do the grouting, here we have applied a pressure 3 MPa, then 5 MPa, then 9 MPa. If suppose that we increase the pressure for grouting more than 9 MPa, it will flow throughout the RBM, because this is not a rock. So in rock we can increase it, but in loose material like this is the RBM, we have to do the grouting in cycle. So we put the grout in section, then we leave the hole for 24 hours to settle the grouting cements. So this is the cutoff drainage. We provide the cutoff drainage for the 7 meter, and this cutoff drainage is situated between the Gyansu village, that is means situated at the right bank of the Joshiara barrage and between the embankment of the barrage. So what is the use of this cutoff drainage? It will receive the water from the saturation zone, whatever means leaking from the embankment towards the Gyansu village. So it receiving the water up to the 7 meter, and after 7 meter we have grouted whole the area, and the whole area is now dried. So so this we propose a curtain grouting in 3 stages: primary hole, secondary hole, and the tertiary hole. So you can see the design plan of primary hole, secondary hole, and tertiary hole. In primary hole, we provide the grouting for 5 meter interval, then 3 meter interval, then we have provided 2 meter interval. So the consumption of cement, basically this is our mixed design. Here we applied the bentonite because we don't use sand here. Sand was our last option during conducting the research work here, because sand choked our grouting machine. So this was our last option. So luckily, or by our investigation, we were successful during M1 and M2. We didn't need to go for M3, M4, M5, or up to M6 grouting design. So here we use 96% of cement, then 4% of bentonite. Previously, there is a thumb rule that we grout the hole up to the rejection of the hole. Here what we apply a new strategy, because this is a RBM. So we apply we fix our grouting limit. We grout the hole in one section up to 20 bags. After 20 bags, we stop the grouting and let the grouting material settle down. Then we go for another phase or another cycle. So why we do this? Because this is a RBM, and it has high permeability coefficient. So if we apply more and more grout in one cycle, it will take means lots of bags of cements or grout material. So minimize the cost. We apply the cycles up to the 20 bags. So these are the design: primary hole, tertiary hole, and secondary holes. So you can see the distance also, and the means. Then this is the correlate between the means primary hole, pre-grouting hole, BH3, BH5, BH6, and this is the center hole. So there is the permeability coefficient was very low, as you can see here also. This is the center hole, and we plot the graph. So this is purple color of graph. So this is the post grouting coefficient of permeability. So you can see there is the 60 to 70% decrease in the intake and the permeability coefficient. So this so this presentation was about the Joshiara barrage and the problem and how we have tackled it. So here geology and geophysically combinedly play a very vital role, as well as the civil engineering. So we have developed a very good methodology to treat this problem. So this was my case study, and thank you very much, because due to this leaking and seepage, Joshiara village was suffered a lot, but now they are happy. Thank you very much.
Okay, thank you very much, Mohit. So, are you listening me, everyone?
Yes, sir.
Okay, so thank you very much. Any questions from the audience, please? Okay, so maybe you can stop your sharing the view. Are you listening me, Draupadi Yadav, Dr. Draupadi Yadav? Hello, Dr. Draupadi Yadav, please share your slides. The role of society for environmental hazards and disasters management. It's okay. Your voice is not first. You unmute your record. Draupadi, please unmute. Draupadi, please unmute.
Okay, okay. Sir, now it's audible?
Yes, yes, yes.
Okay.
Please speak now.
My slides is visible, sir?
Yes, it is.
Okay. So very good afternoon to the to everyone, and I'm very much thankful to the organizer, those who have given me this wonderful opportunity to present my presentation on the topic of society for environmental hazard. And we are living in the era of science and technology, and we know that what to do, why to do, and when to do. Those who are living on the earth, they are the part of the society. We are just enjoying the nature, we are living with the nature, but what we are doing, whether I mentioned this first slide, that due to the different causes, we have made our role of society, what we have did. We are disturbing the earth, or the role of society is very much important. And in the society, not only the government, but the individual, whether they are in different gender, male or female, they are in different age groups, they are student, they are youngsters, they are old age, whether they are children, everybody is just taking part in the society. So this comes to our mind. This mostly the children, just the society, the people, individuals, they thought that we are the part of society, and what is actually the hazard and disaster, how we can be a part in the management system, because it's a part of the government. Generally the people think, those who are just residing in the society, they should first know that what is hazard, agent that can cause harm or damage to human beings, infrastructure, or the nature is called hazard. This is very simple words I have put in it, that types of
Some net speed is the problem.
railways accident, aviation disaster, fire, building collapse, communal violence, bomb blast, and as well as now what we are seeing, that different wars, world wars, the biological war, nuclear war, what we are just seeing due to the participation of different geopolitical reasons and the participation of the society. In that case, what to do, how we can participate. Yes, we can't stop the disaster, but definitely we can reduce the risk. And it's the probability that exposure to a hazard will lead to a negative impact, or a hazard that was no risk if there is no exposure. The vulnerability, what it is, here our responsibility comes first, because it is the inability to resist a hazard or to respond when a disaster has occurred. Public of plain areas are more prone to flood. We know some reason are prone for flood, some reason like hilly areas prone for landslides. Earthquake is also one of the major hazard. In that case, we can reduce the vulnerability. If we mark the vulnerable zone for different disaster, we can reduce the impact of disaster. And what is disaster? Yes, it's an event that causes a lot of harm or damage, of whom loss of life and property. Definitely the society would be impacted due to the disaster. And we have lots of example of the disaster, and we have seen the disastrous event by our eyes as well, like Uttarakhand disaster. We have seen the tsunami. So we have seen the disaster. In that case, the part of the society play very important role. So friends, we know that most of the expert, everybody almost just suggesting and telling, and we also know that we cannot stop that disaster to happen because it's a natural phenomenon. But we can take certainly some steps to reduce its adverse impact on the society and the environment, because we are living in the environment and taking using the different natural resources for our lifespan. In whole lifespan, we are using and we are living with the nature. So in that case, we should take few steps. We should follow the scientific rule. We should follow the scientific facts. As our previous speakers yesterday also mentioned that we should live with the nature and follow the scientific facts, which is very much important. So what we can do as a part of society, we should know the environment. We know that. Yes, the water, air, and land, and the interaction with amongst all is called environment. We are living in the environment, and it's a duty of every one of us. And whether individual is responsible for that, yes, we know the biological level of organization. So from atom to ecosphere, we are here. So we are connected to the nature in each level. And if you see in the spectrum from origin to this current existence, this biosphere, we are living in this nature. So we should also take care of nature. We should not exploit the nature. Then we can survive easily. And why we are
Dr. Draupadi,
thinking we are having good biodiversity. We are very much on the earth. This is beautiful earth.
Draupadi, might be her connection is disconnected. Then Ramotarji,
Ji sir.
your voice disconnected several times. How much time you will take? Otherwise, you can see your connection is
Sir, very
Voice is not. Your voice is not coming, so please stop your. I think. Okay. Maybe the Harshita, Dr. Harshita, Dr. Draupadi.
Sir, I'm audible?
Yes, but very
Yes,
quickly,
sir, I'm here.
please, because your voice is not coming properly.
Okay, sir. I'll finish in very short period of time, sir.
Okay.
Okay. So as we know that we have only one word. Do you want it like this, or we should follow in that case the sustainable development, and we have the 2030 sustainable development goal, and we should also take care of environmental sustainability. And this environmental education and disaster management education is important for the society. It is not only the knowledge but need rapid action, and I'm very much thankful to the organizer because they are just taking the lead in disaster management, because this is conference, this webinar, international webinar, is related with natural hazards and their management. So this is very which already shows.
Okay. Thank you.
It needs, we already have in the society. So we.
Okay. I think. Thank you, Dr. Draupadi. But I understand because there was some internet problem at that institute due to the failure of the electricity. Are you able to listen my voice? Others? Ramatar, my voice is coming?
Yes, it's coming.
Yes,
Okay,
yes.
so maybe Dr. Draupadi, you just stop your sharing the slides. And Dr. Harshita Joshi is ready?
Yes, sir, I'm here.
Okay, just I asked to the Draupadi, please stop your sharing. Draupadi?
पार्टिसिपेंट वन नहीं, आप जोड़िए दूसरे.
Stop your sharing.
ये लिंक लीजिए.
Maybe now Harshita, can you try to share your slides?
Yes, sir, I'm trying, sir.
Okay, just you try to share your slides, then I will remove this one.
Is it sharing, sir?
Not yet, but I check it. Okay,
From
Draupadi,
my
are
side,
you not
it should-
listening me? Draupadi?
Share your screen.
ये लीजिए. आपको भेजूं?
I've shared my screen. I don't know if it is visible there.
Try it again because our participants can share it at the same time.
Okay.
या मुझे भेज दीजिएगा वो अगर आपका टाइप हो.
आ गया? उसमें तो लिख के उसमें जोड़ दीजिए.
एक मोमेंट वाला आएगा
कुमाऊं दो हो जाएगा ना. ये फिर वो सब जुड़ जाते हैं ना. हमको लगता है ना कि गिरीश को हटा दीजिए, फिर वो भेज देते हैं. फोटो भेजा आपको, ठीक है उसमें कोई फोटो?
Okay, Harshita.
Okay, we see.
Yes, sir.
देखो एक ही भेजी है ना?
I am
Is my
sorry.
screen visible, sir?
Yes, yes. Now the slide is visible.
Yes,
and
yes,
Okay.
You are also visible.
Should I start, sir, then?
Yes.
yeah, yes.
Yeah, thank you, sir. Thank you so much. So this is a very short presentation wherein I'm going to show the preliminary studies that have been done in respect of land investigations from Quiti to Rodgaon. It lies in the Uttarakhand region of India in the Himalayan terrain. Himalayas, we all know they have always been susceptible to disasters due to active tectonics causing earthquakes, landslide, and other such disasters. So here, landslides occur in hills, or I should specifically say in Himalayan region, in response to various conditions, the terrain conditions, the triggering factors like heavy rainstorms, cloudbursts, or earthquakes, and other unsafe developmental activities. So in all, we understand that it presents in like the world also. We see various social and economic catastrophes which are to landslides. So hill slope instability, because it gives direct or indirect losses to the people who live here. So the present work, as I already said, it is the preliminary work which I'm showing under the landslide investigation. So the area, it lies from Quiti, as it is shown here in this Google map. It starts from Quiti and it goes to Rodgaon. This lies within the Thal-Munshiari road, and geologically this region, it lies, it nears the Munshiari thrust here. So the aim of this work, the presentation, in fact, which I'm showing right now, is to show you that what basic investigations have been done in the landslides here and the generation of landslide inventory here. So we see a very beautiful, ironical, although this is an ironical word, we have to use this word when we describe landslide as geologists. So a landslide can be portrayed as an episode of, you see, downward and outward displacement, where the movement ranging from very slow to rapid in velocity, it happens due to changes in the slope and the material due to the influence of gravity. So this image, here we can see various morphological descriptions that we use to describe a landslide, as it is shown here: the crown, the accumulation zone, the depletion zone, and likewise. So on the basis of material and movement type, we all know that how slides are divided into false stoppers slides. They may be rotational, transitional. So we saw various similar factors to make the landslide inventory in our area. So here I'm showing you the landslide number 1, which is going towards the Rodgaon village. Locality, lithology, latitude, longitude, and various other factors, the causative factor, triggering factors, type of movement, all these were identified along with the slope. Here in this slide, you can see combination of debris and rockfall. In the second location here, we can see there is debris flow, and this is all RBM there. Here again, this is a debris flow. It is associated with the RBM and some of the faulted material in that region. In this region here, again, this is a debris fall, but again associated with RBM. This is the same image which I showed in the first few slides, because this is a kind of textbook example. This is a complex landslide there. Then again, here we can again see a debris flow. Here again, the debris flow is associated with the small rivulet which comes towards the roadside. And here we can see rockfall, where wedge failure was seen in the outcrop itself. And here again, we are seeing rockfall. The boulders are seen falling in the roadside. Here again, rockfall is seen, and the rotational come slide movements are noticed in this complex landslide here. Here again, debris flow is seen. Here rockfall is seen. And here again, debris flow and some rockfall is seen, and other factors, as I've already said, these were also noted. Here debris flow was again seen. Here also. Here the old landslide was seen reactivated. Here again, the old landslide was seen reactivated. Here again, these three slides were old but reactivated. Here the debris was seen coming into the motorway. Here also the motorway was filled with these rock falls and debris flow. So we see some of the destruction which has been happening due to the reoccurrence of old landslides also in this region. So all in all, what we have done as far, this is, as I already said, the preliminary part of the work that has to be done. The area which starts from here and ends till here, we have marked various landslides as it is seen here, L1, L2, L3, and likewise. So these, now we have a complete set of the landslides which have been occurring here in this region. So this data has been taken from April to December this time. So on the basis of just to try, in order to understand a few things from this, we try to see that in which region more of the landslides are occurring and in which region less landslides are occurring. And on the basis of frequency of occurrence of these landslides, we have tried making a small interpretation. Here, on the basis of the occurrence of these landslides, it can be said that some of the part is more susceptible to landslides in future and some is less. Although a lot of studies is still left, this is just the first part which I have shown in this presentation. And on the basis of these preliminary studies, a few interpretations that we could get is, one is this, which I'm showing here. And so to complete making a gist at the end, it can be said that landslide inventory is the primary requirement when we study any landslide. So we have made a landslide inventory as of now, and preliminary studies have showed that there are debris, rockfall, and complex landslides here. And the landslides are more as we go near Rodgaon village, which nears the Munshari Thrust. So it can be said that geologically lying in the vicinity of Munshari Thrust, the study area it faces active tectonics here. So the landslides which are occurring here, they are controlled by the geological status and also the water which is induced. So further studies are required to make understanding of the mechanism of failure in this region. This is all I have to say as of now. Thank you.
Thank you, Dr. Harshita, for nice talk. Any questions from the audience? Any questions from the audience? Okay, so thank you very much once again.
Thank
Can
you.
you stop your sharing?
Yeah, I'm doing it.
Is Dr. Girish Chandra Kothari, are you listening me? Dr. Girish Chandra Kothari? So probably he don't have the internet connections. Then the next is the Ravi Shankar Dubey. Are you listening me? Deepak Pant? Deepak Pant. So Deepak Pant, what? Deepak Pant?
Sir, I am Ravi Shankar Dubey. Are you here?
Ravi Shankar Dubey.
Yes, sir.
So can you show your slides?
Yes, sir. Yes, sir.
From which ID you are? What's the name you?
Sir, Piyush, actually Piyush laptop used. So Piyush
Okay,
ID.
so you are using the Piyush laptop. Okay, so good. So Ravi Shankar Dubey.
Yes, sir.
So please conclude your presentations within 10 minutes.
Okay,
Make it
sir.
the full slides. Okay, so
Sir, here, I can start, sir.
yes, yes.
Okay, sir. Good afternoon, all respected sir and madam and my colleague. Thank you so much, organizer, to give me opportunity to present this webinar. Today, I am presenting this topic of webinar is evaluation of aquifer protective capacity and soil porosity using electrical resistivity method and in harder region. This is my presentation outline. I will start my introduction. Then what will be the methodology I will be applied. Then after we get after applied methodology, we getting result and then discussion, then conclusion. So we know that the poor quality and inconsistent nature of most surface water supply in arid and semi-arid region of the world has increased the demand of the groundwater resources. The accessibility of the groundwater and anthropogenic pollution in most city and natural community has a major sources. In this presentation, we calculate the protective capacity of aquifer and soil porosity in the part of a Bundelkhand craton from surface water contamination investigated in the light of a geological characteristic of the overburden material for sustainable management. In this study, applied a secondary parameter derived from vertical electrical sounding to delineate the aquifer vulnerability zone. This is my study area map. This is located in 252 kilometers in the southeast direction from Lucknow. This area is the most drought-prone area of Jhansi district. This basin is characterized by poor soil cover and scarce vegetation, erratic rainfall, and lack of soil moisture most of the part of the year. The lithology of the basin is underlain by the Archean rock, and most of the terrain of the micro watershed basin lies in the Bundelkhand craton. Broadly consists of a gneiss complex, greenstone, ultramafic rock, and various type of granotite, which is a highly weathered and jointed found in this area. Those areas, some part of the area, thin strip alluvial deposit like this area. Some part of the area, physiography area is a different type of a feature. Like this area have a subtropical and humid nature. Most of the drainage flow northeast direction. In this apply the method like hydrogeophysical exploration and production. We are the most difficult task in a hard rock area. We use the electrical resistivity method data set in a complex lithology structure to solve the groundwater problem. It has a providing relatively low cost and non-invasive method. In this method belongs to the geological family of a geophysical method, and it is based on the application of electrical current into the analyzed bedrock. A measurement the conduct 1D model of the subsurface. This is the A and B is the current electrode. Here enter this current and measure MN are the potential electrode. Here are measures. We apply the current and measure this potential in between this. Then after we are use the apparent resistivity plot. Plot IP2 in software and resistivity of the layer. We calculate the secondary parameter using this formula, longitudinal conductance using this formula. Here in this figure, Here in this given table, we calculate the aquifer protective capacity on the basis of the longitudinal conductance. This longitudinal conductance value corresponding to excellent. If a high longitudinal conductance value, it may have a good aquifer capacity. If a low longitudinal conductance, it means the very weak aquifer protective capacity. Here in this figure, it is the red color spot represent the very low longitudinal conductance. That means this area has a very low protective capacity. Here, a blue color spot represent this area have a high protective capacity. It means the good chances of aquifer protect. Here in this figure, a table shows that the soil porosity rating. Soil porosity inside this in this study area was determined by the first layer of resistivity. Here, soil resistivity high represent the non-porosity type, and low soil resistivity represent very strong corrosive nature. Generally, corrosive soil contain the large concentration of a soluble salt, especially in the form of sulfate, chloride, bicarbonate, may be characterized by a high acidity, high acidic nature, या low pH value. Here, blue color spot, dark purple या blue color spot, this represent the very low resistivity. The porosity. Then overall expected delivers in my conclusion. In present study, the region of a weak protective capacity are less vulnerable to the groundwater contamination, but can be more vulnerable with time as a pollutant persists. Region where have a moderate protective capacity, then have a good protective capacity region. Serve as a ceiling, have a underline the good hydrological system. This makes the contamination in this area that it is almost impossible. The soil capacity in this study area determine the have a very strong that area represent the VS location have a strong corrosive nature. And some area have a low resistivity, that means have a good chances of a high moisture content of the soil, but not worried in those areas. Some use references in this slide. Thank you.
Okay, thank you, Ravi Shankar Dubey, for such a nice topic. Can you hear me very well?
Yes, sir.
Okay. So, any questions from the audience? Maybe you stop your sharing.
Okay, sir.
Okay, so anyone's the questions from the audience, please. Deepak, are you listening me? Deepak Pant. Deepak Pant, you connected several times and then every time disconnected. The problem is with your internet. Any scientist who have I forget their name for the presentations, please. Anyone share, any scientist, any research scholars who is present here, and I am if I missed their names for the presentations, please tell me. So I think that Deepak has not connected. He connected several times, but might be disconnected every time. Hello, Deepak Pant. Deepak Pant, you are connected with the now disconnect. So.
Okay, Binod ji, kindly call Professor Nageshwar Dubey ji for
Some
giving some
okay.
regarding
Okay,
this
so I think
some idea regarding this conference.
Okay, so thank you very much for your kind cooperation for this 2 days international webinar on the occasion of the 3rd international webinar on natural hazards and management, which is organized by the this Bundelkhand University and in the collaboration with the Karelian Research Center, Institute of Geology, Petrozavodsk, Russia, and my colleagues, Professor Ramotar Singh from the Government Degree College, Garudabad, Almora. So with the help of these 3 institutes, we are able to conduct this internet webinar. And just after some, we will again connect for this all together say a few words about this conference. Might be, I think, after the valedictory sessions. So first, we start the valedictory sessions. Professor T.N. Singh has joined us, and he has given us time for this valedictory sessions from his busy schedule. And then we'll discuss later on whatever. Nageshwar, what you want?
It's okay. It's fine.
So first we listen few words regarding this valedictory session from the Professor T.N. Singh, and then we will say about our words about the lectures and what the, if anything suggestions comes from your end, it will be better. We will prepare for the next times if we manage it. Okay.
Sure.
So,
Sure.
Now we start the valedictory sessions. Artem, it is okay?
Yeah, it's going.
Okay. So
thank you.
Okay, so this is the valedictory sessions. So whatever, I little bit tell you in the few minutes, because in just introductions before the valedictory sessions. So we are very much thankful to
Dr. Sir, Professor V.K. Singh.
Yes, sir.
V.K. Singh, sir. I wish
Yes,
to
sir.
share some. I wish to share some news.
Oh, any good news, sir?
This is Ratnakar from Andhra Pradesh.
Yeah. So this is the Dr. P.J. Ratnakar. Yeah. Earlier he was with us in the Bundelkhand University. Now he joined in the Andhra Pradesh University as a professor. Now there and the head of department in that institute. So might be we listen after. Okay.
Okay. Can I speak?
Yes. Please.
Okay. Thank you, Professor V.K. Singh, sir. I am very much happy to share these views. I am fortunate to be there at Bundelkhand University. I did my service at from 2005 to 17. I was there at Bundelkhand University. It is very good time. At that time, my colleagues, Professor V.K. Singh and Professor Joshi, Professor M.M. Singh and all these guys, they are arranging all this good international webinar. This is the 3rd webinar, I think. So during this webinar, I heard all the lectures. It is very informative. Even though I am having that attachment with that Uttar Pradesh and Uttarakhand area, I heard all these things and these disasters and hazards, good presentations and good informative and very well presentations. And I want to share some news. In the month of March next year, 3rd and 4th, I am arranging one national seminar. The topic is recent trends in geosciences and its applications. Why I choose this topic is this topic is meant for all. Actually, if I restricted for one subject, the participants are very less. So that I decided to conduct on recent trends in geosciences. I request all the participants and delegates to please participate in my seminar, and I welcoming you all. Thank you very much. Thank you for Professor V.K. Singh for giving me this opportunity. Thank you very much, sir.
Okay, thanks. नागेश्वर दुबे जी, हाँ, उनका उनका टैग करवा देते हैं। सर,
I had sufficient time. Let
no,
Professor
sir.
TN
Okay,
Singh.
sir, Professor TN Singh has the meeting in a few minutes. So,
Okay.
please, thank you very much, everyone. So, Professor TN Singh, I would like to request you, sir, please give your some valuable comments for us. Okay, please, kindly unmute.
Thank you very much, Professor Vinod Kumar Singh ji. The seminar which was organized regularly, I think in every year by Professor V.K. Singh and his colleagues. It is a wonderful seminar, and we have a more understanding about not only the India, but this across the India and the other places. This is a great opportunity to see some of my old friends and colleagues to whom I have heard. Some of them, they are doing wonderful research in their respective places. The lecture organized in a very systematic manner, very scientific manner, and you have done a lot of work, I think, before completing this kind of the scheduling, where the mineralogical changes, metamorphic petrology, with the same times you have the natural disasters and this chemistry, geochemistry, all amalgamation of all this complete earth science, I can say. And I see the seriousness of the candidate across the subject, other than the earth sciences or the geosciences. Candidates have been joined in the other allied subjects, which are now a very close to this, some of the general problems of this earth science, particularly once you are talking about the study lecture by Professor Dhruv Singh about the climate change, and Professor Dubey about the basin disaster management. Shantanu Sarkar, he is one of my old friends. He is always present here. Yesterday also I have seen him. Today he is also present. And he has a wonderful experience in the particularly working in the Himalaya. And he is the first person who report many of these landslides in India. So such an experienced person, such an expertise person, you have brought all together. And definitely across this, you can see the continent also, we have the experts and friends. They have also participated very actively and very enthusiastically. Some of these young faces are also visible to me. There is a great learning experience for them. And for us also, it's a great learning experience, and how one branch of geoscience can supplement and complement to this other branch to understand the mechanism of the problem and the root cause of the problem. Because you cannot now work in the isolation. This is the time of the multidimensional thinking, multidimensional approach, and multi-subject approach to resolve any of this particularly and make this program a grand success. From your other side of the colleague from the Russian, they also have contributed a lot.
Artem, some net problem is there?
Yes, some sound problems we have.
Mhm.
I'm not aware how I lost the connection, but anyway, I will not take much time of you because you have this plenty of speakers who are waiting to give their reactions and their thoughts. Once again, I am thankful to the organizers to be given me the yesterday sufficient time to express my view, and today also you have invited me to speak something about this conference. So I must express my gratitude to the organizers and my friends who have heard my, you can say, the speech or my thoughts. Thank you very much.
Okay, sir. Thank you very much for your kind of words. So we will keep this in mind, our mind, that we will be organized next time. So whatever we can do, the little bit better, try to do better. Once again, thank you for your kind cooperation, kind help since last 3 times. And Dr. Ramotar Singh. Dr. Ramotar Singh.
Yes, Binodji.
Please give the vote of thanks to the valedictory sessions and previous sessions. Professor
Okay,
T.S.
okay. Very good afternoon to all. I thank all resource persons as well as participants. Professor Ashok Kumar Singh, Professor Shantanu Sarkar, Dr. A.V. Mukrusin, Professor D.B. Jiro, Dr. Harsita Joshi, Dr. Mohit Kumar Punia, Mr. Ravi Shankar Dubey, and our chief guest during valedictory session, Professor T.N. Singh, IIT Director, Patna. All are have given their important time for this international webinar, and so I am thanking all the participants and the resource persons. Thanks to all. Now conclude, Professor Binodji.
Okay, so thank you, all of you. First, I would like to say whatever the proceedings we will see, that this committee has recommended that this type of the webinars should be continued every year, because after this COVID, our research work should not be fall down. So to maintain our the research idea about the fields, this committee recommended we must follow each year to this webinars. And as usually, that from the inaugural sessions, Professor Mukesh Pandey, the Vice Chancellor of Bundelkhand University, he was busy in the meetings too, and today also we have one selection committee there, so he's busy in that way. Professor Sergei Sveto, he was also very busy yesterday, but he gave us time for this inaugurate these inaugural sessions. Then Professor T.N. Singh, who gave us the very nice talk, this one. Professor C.S. Dubey, the Vice Chancellor of this K.R. Mangalam University, and Professor Dhruv Singh. So these persons, renowned persons, given us time. So thank you very much for all of you. And in the scientific sessions, we have a lot of discussions. Just I will tell only the few names. The Professor Vitali Chekoy, Dr. Lebedev, present here from the Institute of Geology, Karelian Research Center, Petrozavodsk. Dr. Lokesh Sinha, now he is the ex-director of this DTRL DRDO, New Delhi. YP Sundaryal from the Galwan University. Then Asalata Singh from BHU. Professor Yashi Bhatt, my colleagues. And Sardar Prasad Pradhan from the IIT Roorkee. Piyush, his students, and then the Tapua from the South Africa. And then today's talk is in the scientific sessions was the Ashok Kumar Singh from Lucknow University. He is the department from the physics. Shantanu Sarkar from the Roorkee, CBRI. Then Makru Sen from the FRTT, Kola Science Centers. And then Harshita Joshi, Draupadi Yadav give their talks. Mohit Kumar and Ravi Shankar Dubey. In the last valedictory sessions, we are very much thankful to Professor T.N. Singh for his giving the valuable suggestions, and we will follow him. Okay. So this is the all the conclusions. But now we give some times to the my colleagues, my audience, some audience, and some wants to say some few words for you, Dr. Amrita Singh. Kindly allow them to say a few words about this 2-day international webinars. So please, first, Dr. Professor Nageshwar Dubey. So, Professor Ramodarji, he want to say a few words for you. So for us, for about this webinars, Professor Nageshwar Dubey. Please.
Yes.
Nageshwar, Professor Nageshwar. First you unmute your voice. Unmute, please.
Okay. Okay. So, is my voice clear?
Yes. Now it is clear.
Because I am from my mobile data, not
Okay,
from
no.
the.
It's no problem, sir. Just
Okay. So, first of all, a lot of thanks from my core of the heart for organizing such beautiful event.
दोबारा लिंक जुड़ पाए
कुछ कर रहे हैं क्या रामोतार जी?
might be he's busy in his professor, his principalship.
Okay, no problem. So, as you know, in current scenario, it is very difficult to organize, whether it is webinar, seminar, workshop, particularly in geology field. Everything is becoming day by day challenge. Even the field works where we are going regularly, it is also becoming a challenge. Earlier, some 10 years back, 20 years back, when we were visiting with our students in the remote area, so our farmers, local neighbors, they were very much cooperative. But nowadays, for geology people, even organizing the field work is very difficult in the remote area. And sometimes farmers, they think that we are the enemy. हम ही लोग दुश्मन हैं, because we are exploring the gold, petroleum and other things, then government will occupy their land and they will be evacuated. So ultimately, if geologists are not allowed to visit the area, their life will be safe. So your natural hazard and management topic is very nice, but already we have conducted 3 times on the same topic. So if possible, next time, if possible, my suggestion will be the challenges for geological people, particularly in the field or in the lab, what type of challenge day by day they are emerging and how we can try our best to solve those challenges. And regarding the natural hazards, most of the hazards, they are natural, but many of the hazards, they are man-induced, anthropogenic also, isn't it? So if any landslide is occurring because of the negligence, poor study, it is not natural hazard. It is anthropogenic hazard because people, they have not taken sufficient care and they jumped in a well. So sometimes mistakes, they are also causing the hazards. So topic is very good. And if possible, next time include the emerging challenges of geological studies also. This is one point. Maybe it looks funny, but it is serious because whether it is Africa or whether it is India or whether it is Europe, problem is same. Geologists cannot work in the lab; they have to go in the field, and the field life is becoming day by day very tough. So this is my one suggestion. Second suggestion is, if somebody is interested to work in the Jurassic Cretaceous of the Ethiopian side, my cooperation will be always there. And if somebody is willing to visit central India, particularly Son Valley, Chopan area, Porcelain Heights, Kajrahats, so I am ready to cooperate them, whether for the field or for any other research activity. So again, my thanks to the organizers to continue this program with same enthusiasm, same energy, and my best wishes and cooperations will be always with you. Thank you very much.
Thank you, sir. Thank you very much for your kind words. Any more audience to want to share your words regarding this webinar, with shortcomings, or you want any suggestions? Give suggestions, please. Audience, please. Anyone's, please.
Draupadi Yadav, you want to say something? Your lecture is somewhat net problem, so you can say a few words.
Dr. Shantanu Sarkar is saying few words.
Yeah, thank you for organizer. It is a wonderful seminars, and you can see a lot of good work in the different aspects of geoscience, engineering, geology, or disaster mitigation and other things. And I am seeing it for last 3 years. Maybe next year, if you can organize, I don't know whether it is possible that in a hybrid mode, so that you can have few persons physically and few persons who cannot join can come with a online mode. So the interaction with the students will be very good. Out of conference time, if we can have a lot of good interactions, so that you can think of the next time if you can have a hybrid.
Okay, sir. We will try to see our limitations and
yeah.
Okay, sir. Thank you for your kind suggestions, sir.
Thank you.
Okay, I think we will try to go a little bit more offline, a little bit, because it was happens in the COVID times, and that due to this COVID, everybody was tagged in their limitations. So now when the COVID is nearly finished, or it must be finished as early as possible. Might be Dr. Draupadi, please wait. Dr. Vitali, you want to say a few words? Dr. Vitali?
Yeah, I'm here.
Yeah, but you want to say some suggestions for either the research or for this such type of the webinars? Can you also open your video too?
Okay.
Thank you. Okay, few.
I see. So what can I say? Really, such kind of webinars are very useful for our activity in our work. Yes, and I see that a lot of new information, a lot of interesting reports, new ideas. And for me, for example, I saw even something new for me in concerning to the space weather for example, it's unique to my opinion. So I think that such kind of conferences should be continued in the future, because it can give us new possibilities to communicate, to work together, and so on. Yeah, that's all. I can speak a long time, but I understand that it's not needed. Have you heard me?
Yes, Professor. Yes.
Yes,
Very
yes.
nice. Very nice.
Okay, so I can say thank you, everybody.
Thank you very much, Dr. Draupadi.
I'm audible, sir?
Yes,
Yes, audible, but not
Thank you.
not with the video. Okay.
I'm
Okay.
visible, sir.
I think we have the internet speed problem. Okay, please say.
Yes.
Whatever you want to say.
Okay. Very good afternoon, sir. Literally, this conference, because I have joined last year also and this year also, so it's always supporting to the students, to researcher, and also giving lot many things to us, because we are also updating with the data too. Because as we are talking about the hazards, I think so that technical hazard is also should be included in this hazard part, because internet connection, electricity, where we can almost manage, but sometime it happens, so we face problem. So technical hazard would be also included, sir, in this. And I have the expert is literally always giving lot of new things, new ideas to learners, as we are also a learner. So we learn from each other. Every presentation, every expert have seen yesterday and today also the presentation. These were extremely well. And now what is going on in the scientific institution, like the Sarkar have presented their landslide this landslide topic. So we have seen, yes, what is going on today. We are not only studying that, okay, this part, this landslide, this has happened. This is real time, the analysis, how they are implementing. We have also updated with knowledge. And all the experts have done well. For that, thanks to the organizer for organizing this wonderful conference. And I have few words, if you allow, a few lines for this conference, because as I am environmentalist, so I want to put few lines. हर तरफ हर जगह हर कहीं पे है हाँ उसी का नूर रोशनी का कोई जरिया तो है हाँ है कहीं पे जरूर ये आसमां ये जमी ये चांद और सूरज क्या मिटा सका है कभी कोई भी कुदरत क्या मिटा सका है कभी कोई भी कुदरत कोई तो है जो करता है मुश्किल हमारी दूर हर तरफ हर जगह हर कहीं पे है हाँ उसी का नूर हाँ उन्हीं का नूर. And these lines are dedicated to the organizer. Thank you very much. Thank you.
Okay, thank you, Draupadi. I think Dr. Makrusin. Dr. Makrusin. So
yes.
So please give some words for us, for this organizations, for this anyone suggestions for the next times.
Thank you for give me opportunity to participate in your webinar this year. And I hope that our scientific community will grow, and more our scientists from Kola Science Center will participate in our future webinars. So thank you very much, and see you next year.
Okay, thanks very much. Professor S.C. Bhatt, my colleagues, Professor S.C. Bhatt. Professor S.C. Bhatt, are you unable to listen my voice? And P.K. Singh.
Yes,
P.K.
Suresh.
Singh. Pradeep. P.K. Singh the Pradeep. Yes, Bhattji.
Yes, yes.
So I am very much thankful to, just wait, I am very much thankful to Professor S.C. Bhatt, my colleagues. He is always giving me all the times, give the supports to make these organizations. He is equally responsible and he is equally valued persons as the coordinator too. Please don't take other way. But
no. Thank you very much. Thank you very much.
Okay.
Actually, it was a very, very nice webinar. And yesterday, since the beginning, from the inaugural session, we have heard a lot of renowned speakers, and we have heard a lot of things about the disasters, natural disasters of Himalayan terrain, and Professor Dubey, Professor Sundaryal, they have focused on the various problems of the Himalayan terrain, that is basically the landslides and the erratic rainfall patterns and the climate change and the extreme weather conditions which are going there. And then all the Russian fellows, they have also delivered very nice talks on the different topics. So it was a very, very good deliberation and good deliberation among all these the scientist fellows, and we have shared and we have debated on all various problems related to the disaster, whether it is a landslides, or it is a seismic activities, or it is a mining problems, and we have listened from all the renowned fellows. So it was very nice talk. And I also actually thankful to my colleague, Professor B.K. Singh, Professor Ram Avatar Singh, and you both fellows, you have given your lot of energy, lot of time, and continuously you have been organizing this webinar since last 2 years. And I hope again, you all people, you will be again able to organize in next year. And I hope more speaker would be there, and we will organize as Professor Sarkar has mentioned. So if possible, it would be in a physical mode, if possible. Then all the speaker, once again, I am extremely thankful to all speakers, all Russian fellows for organizing this beautiful or this knowledgeable webinar. Thank you very much from my side. Thank you, Vinod.
Thank you, sir. Thank you. Thank you. Any audience want to say some few words? Any audience, please? Okay, then I call in the last, but not the least, and today, he is also equally sharing their time, their hard work regarding this webinars since 3 times, and that is the Dr. Artin. Lebedev from the Institute of Geology, Karelia Research Center, Petrozavodsk. So please give your some valuable suggestions, some words, and then end this webinar and stop the recordings. Okay. Artem, please.
Okay, good day to all. I want to thank all the participants, speakers for 2 great days. I hope the webinar was very helpful to everyone. Also, it shows that the control and monitoring of natural hazards is very important in the current realities. And special thanks to the organizers of a wonderful seminar. I hope it will continue and hope to see more participants, more students next year and after that. Thanks.
Okay, so all of you, thank you again, and wish you a good day and wish you a good times in your careers. So okay, so we should stop this, we end this webinar here, and so hope see you again, and we will try to make the more collaborations and cooperations for the such scientific outcomes. Okay. Thank you everyone, sir. Okay, bye bye.
Okay, bye bye.
Bye.
Bye. So see you. Maybe Artem, you asked to stop the recording now.
Yes, of course. I will set to technician to stop the recording and streaming.
Okay. Okay, who is the speaker Singh? Pradeep is here.
No, PK Singh is Piyush Kumar Singh.
No, but his name is also Piyush Kumar Singh. By two.
Oh.
Wait 1 minute. Okay.